Okay, so I just want to go through a couple problems. We'll shoot to go through a couple of these, and hopefully the palm of my hand won't draw too much on this Chromebook face. So the first step is to draw the elements that you see. I see a nitrogen and I see a hydrogen. See a nitrogen and a hydrogen. And so I'm going to draw the letters directly under the arrow. So the arrow is right here. And so that's where I'm going to draw. So I know that everything to the left of this needs to go on this side. Everything to the right of the arrow needs to go right here on this side. All right, let's change colors. So we've got over here, looking at the ends, there's an invisible 1 here, an invisible 1, just showing you that there's a coefficient of 1 there. So if you see no coefficient, it's not 0, because if it was 0, this would not be here at all. The coefficient that's there is 1, so if you want to draw that in, you can. You don't need to, though. There's 2 ends. I'm looking at this 2. There's 2 of them, so I'm going to draw 2. On the as far as hydrogens, there are 2 of those as well. Going over to the right side, there's 1 nitrogen. It's not written there, but there's a 1 there. And then for hydrogen, there's a 3 that tells us that there's 3 hydrogens. Well, I'm not balanced at all. I've got 2 nitrogens on the left and 2 hydrogens on the left, and 1 nitrogen on the right and 3 hydrogens on the right. So let's go ahead and start figuring out what we can do. The only thing we can do, well, there is a 1 here, so we're going to make this a 2. If we make that a 2, it's going to be 2 times 1 for nitrogen. That's going to be 2, because NH3 means that there is an N, H, H, and an H. There are 3 H's there. And so instead of saying NHHH, we say NH3. So there's so we got that and the hydrogens. So looking at the hydrogens, we've got part of the molecule. There's 3 hydrogens. But because now there are 2 of this whole molecule, there's, if we're keeping, sorry, I'm trying to erase. If we're keeping with what we were doing a second ago, we've got NHHH. And so there's 1 NHH, there's 2 NHHH. So that's, instead of writing all that, we write just this coefficient 2, with the molecule being here. So NH3, that's going to be 2 times 3, which is 6. And it's not balanced. The nitrogens are balanced really nicely, but the hydrogens are not. So let's go over here to the hydrogen side on the left. To the left side, let's look at hydrogens. We can put a 2 right here, and that's going to give us 2 times 2, which is going to be 4. That's not going to be enough, so we can add that up to a 3. So that's going to be 3 times 2, and that's going to give us a 6. Now we've got 2 nitrogens on the left and 2 on the right, 6 hydrogens on the left, 6 hydrogens on the right. So the answer for this one would be 1, 3, 2. See a 1, 3, and a 2. All right, we're going to do these next ones a little bit faster. Again, first step is draw out what we've got. Every capital letter and the lowercase, if it's there, is going to be a new element, a separate element. So we've got 1 K, which is potassium. We've got 1 Cl. We've got 1 oxygen. If you're on a test and you're not sure if this is a capital letter or not, maybe you think it's an I or something like that, then please feel free to ask. But you can see that I think most of you can tell that that's a lowercase, but if you're not sure, ask. All right, so how many potassiums are on the left? How many Ks on the left? There is 1 K. Ooh, let's change colors. There's 1 K on the left. Got 1 K on the left. How many Cls? There's 1. There's a little subscript right here on all of these numbers. You don't have to see them. You don't have to write them, but just know that they are there. So there's 1 Cl. There's 3 oxygens based on that. On the right side, there is 1K, there's 1Cl, and there's 2 oxygens, and I'm basing that off of the subscripts. All right, so we're not balanced right here. So the potassiums are balanced, the Ks are balanced, the chlorines are balanced, but the oxygens are not. So I'm going to go around the long way. There's a shortcut. Some of you may see the relationship between this 3 and this 2. And that may make you want to go ahead and put certain numbers in. That's okay, but I'm going to go the long way around in case you don't see it. So you've got less on the right side than on the left. So let's increase this to 2. That's going to be 2 times this little 2, which is going to be 4 on this side. Oh, well, shoot. Now the left side is not balanced. So we need to come over here to the left side, and we can add a 2 to there. Because remember, it's a 1. That's if it's invisible. If it's not there, there's a 1 there. So I go to the next number up, which is 2. So now we have to reassess everything that we just changed. Everything that's in this molecule, we need to reassess. So K, now there's 2 Ks, and there's 2 Cls. And now there are 3 oxygens times 2. 3 times 2 is 6. Well, shoot, now the oxygen over here is off. So I'm going to come back, and I'm going to put a 3. I'm going to go one number up. And 3 times 2 is going to give me 6. So I've got, I missed one. I'm so sorry, guys. Look. See, that's why I go back and I check. So I'm missing something else here. Now I've got a 2 and a 1, and a 2 and a 1, and those are all not balanced. So it's nice that I have this oxygen balanced, but I don't have the other ones balanced. So let's go back and see K. I've got a 1 there, so I'm going to add a 2. So now I've got 2K, and I've got 2Cl. Now let's go back again. We've got 2 and 2, 2 and 2, 6 and 6. Yep, we're good. Let's go ahead and write the answer for this is 2, 2, 3. And we see that right here, 2, 2, 3. All right, let's pick it up. Let's go do another one. Again, we're going to write the elements that are here, each individual element, and we're not going to write NaCl. We're going to write Na, Cl, and F. There's another way if y'all want to write it this way, then you can. I don't normally write it this way. You can write Na. No, I'm just going to keep it the way that we normally do. If you want to write NaClF over here, and NaCl and F over here, you can do that. I don't do that. That's more writing than I want to do. And call me lazy if you want to, that's fine, but I like just having it right here in the middle, ClF. But if that's what you want to do, if that's what makes sense to you or makes it work, perfectly fine, go ahead and do it. So there is 1 Na, there is 1 Cl, and there are 2 Fs. On the right side, there's 1 Na, there's 1 F, and there's 2 Cls. All right, so now we got one's heavier, one's got more on the right, one's got more on the left, and just because this adds up to 4 and this adds up to 4 does not mean we have it balanced. And just because I can't just come in here and say, hey, this is going to be 2 and this is going to be 2. Hey, look, I'm balanced. This thing down here, this area down here, is your scorecard. So just like in putt-putt, you can't just take 15 attempts to get the ball in the hole and then just put down on a scorecard that you got it in 3. That's cheating. That misses the point of the game. In the same way, you can't just come down here and change these, or you can't come over here and just change this and then make that work. You've got to actually balance the equation. So sodium, we're good. Chlorine, we're not. And fluorine, we're not. So let's come over here. We'll add a 2 to sodium chloride. So that's going to change the number of sodium. It's going to change the number of chlorine. And now we reassess what's even. Oh, our sodium is now off. So let's go over here to sodium, which also happens on this side. It happens to have sodium and fluorine. And so changing this is going to fix both. We put a 2 there. And so there's 2 sodiums and there's also 2 fluorines. Let's see if we're balanced now. We've got a 2, a 2, 2, 2, 2, 2. The answer to this one should be 2, 1, 2, 1. So the first one is 1, 3, 2. The second one is 2, 2, 3. And the third one is 2, 1, 2, 1. We're going to do number 4, and we're going to call it quits. I'll move this up a little bit. So do the same thing, H and O. If you've been paying attention to class, I feel like I've done this 1,000 times in class. With a light brown, I can see that, yeah. So hydrogen, on the left side there are 2. On the left side there are 2 oxygens. On the right side there are 2 hydrogens. But on the right side there's only 1 oxygen. We can't just come over here and put a 2, or just scratch that and put a 2. It's not how it works. So we're going to come over on the right side, and we need to add a 2 to there. So now there are 2 hydrogen molecules. It looks like this: HHO, HHO. There's 2 of them. Instead of writing HHO, we say H2O because there's 2 H's. And instead of writing HHO, HHO twice, we just put a 2 right here, and that tells us there's 2 of this molecule. So hydrogens are going to change. Now there are 2 times 4. I'm sorry, 2 times 2, which is 4. And oxygens change. It's 2 times 1, which is 2. Hey, are we balanced? Got a 2. Oh no, we got a 4. We got to go to the other side. So go over to this other side. We're not going to change anything here. There's no reason to. We're going to change here. We got a 2 times 2, which is 4. Let's see if it's balanced now. We got a 4 and a 4, a 2 and a 2. It looks like it's balanced. So the answer is this number, and then this number, and then this number. It's going to be 2, 1, 2. So the steps for each thing is to list the element that's there. That's what we're doing. Let me see if I can get a highlighter maybe. You list the elements that's in the equation, and then you count the atoms for the elements that are on the left side. You count the elements that are there on the right side, and you put them just like we did. You put them in the space. If it's balanced, fantastic. If it's not, you need to add coefficients to whichever line is missing atoms. And then you recount the atoms, all the atoms on that side. And if it's balanced, great. If it's not, you're going to redo steps 3 and 4, which is asking, is it balanced? If no, add coefficients, recount the atoms. You're going to do that over and over. Add coefficient, recount the atom, and then you're going to add coefficient. You're going to see if it's balanced, add coefficients, and then recount the atoms until it's balanced. You're going to do that over and over, and it may take you 4, 5, 6 times to do it. So the more you do it, the better you'll get at it, and the more you'll start to see patterns, and you can take little shortcuts. But you can do these 4, check your answers. This is 1, 2, 3, and 4.